Hey everyone, welcome back. So we're going to be moving on in our sketching graphs section. We're going to be moving on to sketching graphs by completing the square. So we've done a fair bit of work with completing the square in our earlier chapters, so factorizing quadratics, all right? So we're going to be using that same sort of process, all right? So one approach to graphing quadratics when they're in the general form is by completing that square, all right? So just quickly, Hazy 11 Methods, Chapter 2D, Point 2 and Point 3. All right, that's what we're going to be looking at today. The easiest way to demonstrate sort of how this works is by actually doing an example for you. All right, so we have our quadratic here. So we've got y equals x squared, take 8x plus 9. All right, we haven't been able to find anything that sums and products this. We can't factorize it nicely off the top of our head. We're not quite sure what to do. So what we're going to do, we're going to complete the square. So remember, completing the square is adding a factor of the coefficient of x divided by 2 all squared to both sides, okay? So what that's going to give us, we're going to take this term on our left-hand side with our y variable over to the right-hand side by taking it away from both sides. We're going to solve the inside of this term, all right, leaving it in this form because it's super easy for us to then factorize. And then we're just going to leave this like that for now, okay? So when we have our quadratic in this form, a squared plus 2ab plus b squared, we know we can factorize that to a plus b all squared. So in our case, b is -4, okay? So that means we've got x take away 4 all squared, and this -7 comes from us solving 9 take away -8 divided by 2 all squared, okay? So now that we have it in this form here, okay, we can easily pull out that vertex. So the vertex coordinate is the opposite sign of the value in our bracket, so 4. And then our y coordinate is just the value that is on the end here, so -7. All right. So remembering back to translations, okay? So we did translations during our functions and graphs topic, okay? So if f of x is our original function, f of x take away a is a horizontal translation, and f of x plus b is a vertical translation, okay? So if our original function is f of x equals x squared, therefore f of x take away 4 takes 7, so we're translating our original f of x. That's equal to x take away 4 all squared, so substituting x take 4 for x, and then taking 7 on the end. And this is exactly what our function above is, okay? So we have a right translation of 4 units, so horizontal translation to the right of 4 units, and we have a downward translation of 7 units because we've got that -7. So we can actually graph our new function using translations. It isn't the most time-efficient method, but it is really cool how it ties together an older concept that we've already worked through and applying it to the new stuff we are learning. So you can see here our original function y equals x squared. We've translated it 4 units across to the right, so I've just taken the key points, and then we've also translated it down 7 units, all right? Just be aware of the scaling. It looks like we've translated it across 7 and down 4, but with my scaling on my x and y axes, we've actually translated correctly, my apologies. And then we've got our new function y equals x take 4 all squared, take away 7, all right? So that is one method for doing that, all right? You can also just take out the vertex, all right, and then find another point on there to graph. The next thing I want to run through is quadratics in general form and graphing them from the information that you have there. All right, so remember, a quadratic in general form will look like this: y equals ax squared plus bx plus c. We know the roots of these quadratics take the form x, take away b plus or minus the square root of the discriminant. Remember the discriminant is b squared, take 4ac, and that's all divided by 2a. So that is exactly the quadratic formula, all right? So we know that our x-intercepts are of this form. So if the discriminant is greater than 0, that means these are our x-intercepts. Our axis of symmetry, all right, will give us negative b on 2a. So if you take the average of negative b, take the square root of the discriminant over 2a, and minus b plus the square root of the discriminant over 2a, you'll get that the x-coordinate is negative b on 2a, okay? And as we have already discussed, our vertex will have the x-coordinate of the axis of symmetry. So our x-coordinate of the vertex is negative b on 2a, all right? Making sure that we are labeling our quadratic, our functions on our graph, making sure we are also labeling our axes, all right? So steps for graphing a quadratic in general form, all right? These are some really useful steps, really systematic steps that will make sure you are graphing the correct graph at all times. So step 1, find that axis of symmetry. So x equals negative b on 2a. That's the easiest place to start. We know that that is where our quadratic is going to lie. Step 2, substitute that x value that we've just found into the quadratic to find the y-coordinate of the vertex. So remember, this x value of the axis of symmetry is the x-coordinate of our vertex, okay? So substituting that back into the quadratic will give us the y-coordinate of the vertex. And then we have the whole coordinate for that point. Number 3, state your y-intercept. So remember, y-intercept is when x equals 0. Most of the time, that will equal your c coefficient value. Step 4, finding the x-intercepts. You can do that by solving ax squared plus bx plus c equals 0. You can do that by factorization, by the quadratic formula, or by technology, okay? So there are a few methods you can use. All right, once you do all 4 of those steps, you will have enough information to accurately graph your quadratic. All right, if you guys are all happy with that, you guys can attempt questions 2D.2, question 1 and 2, 2D.3, 1 and 2 as well. All right, we will see you guys next time.